Welcome back for round two of the shader tutorial. We're going to take off where we left last time. Unfortunately, we still have a little bit more background information to go into, so we're not going to get to jump into the really fun stuff just yet. But after this one, we should be, the next tutorial, we should be able to dive right into textures and lots of other fun stuff. There's a little bit more of all the incredible amount of background information to go over. Last time we introduced a ton of stuff, so we're just going to explain some of the more important ones in detail that are going to be important going forward. So we're going to start off with pretty much the same scene we had last time. The only difference is we have a little white plane in the background here, and you can see it's just behind the other objects there. And we're going to start with the same pretty much the same shader we had. If you remember, we had this just color shader, and we were setting up properties, and we'd set up this color property, and we had this so that the color property gets set and we return a color. So we're going to keep this pretty much this exact same shader. It's just going to have a whole bunch of commented out stuff in this new one. So if you look at the new one, there's just a bunch of stuff here commented out, and we'll dive into that information in just a second here. So we had our tester material, and our tester material had our little tint color here. So we still have this, and you can change the tint color here just like before. All right, so let's dive on into the shader here and see what we have. So first thing is we're gonna have we put this zwrite off command in here, and what this is doing is it's basically telling Unity not to write to the depth buffer. And when we're dealing with transparent objects, most of the time, in almost all cases, you're not going to want to write to the depth buffer. And the reason for that is the way rendering works is objects that are closer to the camera that occlude things that are behind it will be drawn, while the things that are occluded won't be drawn. So if we don't write to the depth buffer, we're basically telling the rendering pipeline, hey, don't occlude anything behind us. And when it comes to dealing with transparent objects, you don't want to occlude anything behind the transparent objects. So we're going to go with the zwrite off for almost all transparent cases. Okay, so moving on down to here, there's a bunch more stuff in our vertex input. So previously, the only information we had in our vertex input was the position. So now this is the full vertex input structure now. This is all information that, that Unity will provide for us in that vertex input struct. So this is whenever I'm making a shader, I'll generally just start with this struct and then write the shader and then just delete the stuff that isn't necessary. So with shaders, it's really important to do the absolute least amount of work possible. And removing all this input and simplifying shaders is huge for actually writing good mobile shaders that are fast. But for this particular shader, we want all this stuff in here because we're going to visualize some of it so that we can see actually how we can how these parameters look, and also see a couple tricks for debugging shaders. So we saw the vertex attribute already last time, and it's the position of the object in object coordinates. So next one here is the tangent, and this is something that if you're dealing with 3D models, you can set up your tangents in there, and it's used for lighting and a few other things. But the built-in primitives in Unity don't have any tangents, so we won't be able to visualize this too well. The normal is your surface normal, and that's also in object coordinates, and that's something the Unity primitives do have. And most of the time in your modeling, you're going to have normals. They're completely required for lighting and various other things. And now we have our two UV channels. So we have text coordinate, and this is the 0th UV set, and text coordinate 1, which is the second UV set, or I guess the first UV set if you want to be technical. And then we have color, which is the vertex color. So this is the full struct, all the information. Any of these these values that you have in here, Unity will automatically fill for you, assuming they exist. Now, in the case of vertex color, this is also something the Unity primitives don't set the vertex color, so we won't be able to see that. So going back into our vertex shader over here, our vertex program, you can see there's a bunch of stuff over here that's commented out, and these are just a few handy things for actually being able to visually see what these values are. And when you're dealing with shaders, there's no such thing as debug logging or setting a breakpoint or anything like that. They're just called way too many times for that to be all that useful. So you have to kind of learn to visualize these things by just setting your colors and kind of normalizing them to the 0 to 1 range. So if remember, all a color is 4 values. So it's the RGB and alpha. So first thing we'll do is we're going to set the color to text coordinate. So if we jump back over here, you can see that we're getting some neat little colors in here. So this is a handy way to be able to visualize what's happening in there. So the texture coordinates are always going to be just 2 values. It's basically a vector 2, and if we spin this around, we can get a good look from all angles of the texture coordinates in there. The text coordinate 1 is more or less just the second UV, so it's not anything too important to see there. So let's have a look at the vertex value. This is a position in object coordinates. So for these Unity primitives, that's going to be a value from negative 0.5 to 0.5. And you could see in the sphere, for example, we have a bunch of black down here, and that's because these are all negative values. So just going to uncomment this next line. And what this next line does is it just takes the vertex value and adds the vector 0.5, 0.5, 0.5. So that'll basically just shift it. It'll bias the vertex value so that it's now between 0 and 1. And if we go back over here now, we can get a better look at what's happening in here when we look at these now. And next up, tangent doesn't there's not much to see there. Normals are another one here. So normals, we're going to want to also get those in a range of 0 to 1 so that we can visualize them. So if we just multiply them normal by 0.5 and add 0.5, that'll get us in the value we want, and we are going to just set the alpha component to 1 here. And now we can see our normals. And it's more interesting to look at these on the objects that have some curved surfaces, whereas you see our cubes just have normals that are firing out in only a single direction. So this is something we haven't seen before, which is the way that this float 4 is constructed. And when you're dealing with shaders and you're making float 4s, float 3s, or any of the other parameters, they're really flexible in the way that they can be set up. Basically, they're constructors. So you can pass in something like this, and we'll get rid of that. And what we're going to end up with is pure white. So if you pass in just a single value, then it's going to automatically take care of setting all 4 values to this. And just also, for example, here, if we set it to 0.5, we'll get a half transparent gray there. So these are they're really flexible the way you can make them. So in this particular case, let's just pass in i.normal. So if we look up here, normal is a float 3. So if we pass in just i.normal and say 0.5, it's going to take the first 3 values of this normal and set that to the R, the G, and the B, and then we have our opacity here, which is 0.5. And you can see we get exactly what we expect from that. So they're nice and flexible when dealing with our float 4s here when we're in the shader. Okay, so these are really handy little things. I actually keep this in my shaders all the time, just so that I can I can jump in and add little debugs in here and visualize what's happening. Now, last time we talked a little bit about these blend equations, but we didn't really go over too much. I put a link in the last video tutorial to Unity's blend modes documentation, which lists all of them, which is super handy. Now, the way that this blend mode works is, if we remember, we get to specify basically two things here, and we can specify from a series of different things. Like, we don't get to actually specify with digits what these are, like with actual numerals or with an equation. We have to use these built-ins, and each of these will handle the blending slightly differently. And this right here is the actual equation that's used. So source factor times fragment output, and then added to that is the destination factor times the actual pixel color in the frame buffer. So the source factor is one of these. So in this particular case, it's source alpha, but you can also do 1, 0, 1 minus the destination color, source color. There's a bunch of different options in there. And basically the way it works is it'll just plug in the value into this equation. So if we say source factor of 1, for example, then it's just going to be 1. In the case of source alpha, in our source is the fragment output. So that's the value that we're spitting out here. This is going to be the source. It would just end up being the alpha component of that times the fragment output. So it basically just substitutes those values, and it's a really simple equation there for the blending. But the important piece of this is we can see our destination factor is always going to be the actual pixel color that's already in the frame buffer. And that's important because when we're ever rendering, depending on the order in which we render things, this pixel color is going to be different. And we'll do show a couple illustrations of that in just a moment. There's just one more thing you can do with blend equations here. So we have the blend op. So this is a blend operation. So in this case, what we're doing is we're adding these together. So we're multiplying the source factor and the fragment output, and then adding it to the destination factor times the frame buffer pixel color. But we can also, instead of doing that, we can do a couple blend ops. Unity has, I believe, 4 blend ops. So in this one is going to be the min. So we can see in this particular case we're going to get the minimum value of this. So whatever's smaller is going to be what gets dumped in there. And if we dump a max in here, now we can see that this it's a little bit more interesting. So in the case of this yellow sphere here, this is in front of this plane. So we're going to have two different colors in here. We're going to have this yellow and we're going to have the white. And the maximum value is the white, because white is 111 in the RGB channel. So this is going to be the color that actually gets written to the frame buffer, because we're doing that max in there. And you can hop in Unity's man pages or the documentation to have a look at the other blend operations. But the min and the max are going to be the ones that are most used. Okay, so the next thing we tossed in here is this ZWrite. So let's actually just see an example of how this is working. So in this particular case, we're not writing to the depth buffer. So I'm gonna put these objects in the geometry queue. So if you remember to do that, we just set the queue to geometry, and this gets us back to where we were before. So we're in the geometry queue. Now we're being rendered at the same time as this white plane over here. So all these objects in the front are being rendered in that exact same queue. So if we put in a -1, what that's going to do now is that's going to end up putting us, we're going to be rendered before that plane. So if we go back over here, we can see now that even though these objects are in front of the plane, we're getting rendered before the plane. So we don't actually show up in the actual camera preview here, except for the little parts that are showing over the plane. So this is an example of where Z-Write can significantly change the way things work. So now if we stick Z-Write on, we're now writing to the depth buffer. So this object, even though it's rendered before this plane, when the GPU actually goes and sees the depth buffer, it's going to see that this is actually in front of the plane, and because of that, it's still going to render it, and it's going to occlude this. Now, you'll see our colors got kind of wacky when we did that. But remember, this sphere was yellow. Now it's green. And the reason for that is because we changed the rendering order, the way our blend equation is going to work is different. So going back to this blend equation, this is the part that's going to be different, the pixel color in the frame buffer. In the first case, when we were actually being rendered like this, so now we're being rendered after this plane. So the plane is in the frame buffer at this point. There's a white pixel behind the sphere. So we're going to blend with that white pixel behind the sphere. If we jump into a queue that's before the plane, what's happening now is the actual color that's in the pixel buffer here is going to be this background color, so it's blue. So we're blending the blue and the yellow, which is giving us that green. And we can see this right here by just changing the color of the camera. You can see we're actually changing the color of all these objects here. So it's extremely important when you're dealing with transparencies that your rendering order is the way you expect it, or else you'll get some oddities like this. You know, 'cause even though we're in front of it, we're going to be blending with this background color, which may be something you want to do, but it may also be something you don't want to do. All right, so let's turn Z-Write off, and now we can go back here and we can see we're rendered behind it, and we're being blended with the blue background again. But because we changed that rendering order, now we're behind this white plane. I'm going to put us back in the transparent queue here. And I'm going to leave Z-Write off. So we're now blending exactly how we'd expect in the order in which we are actually in the scene here. And there's a new little shader in here. So we have a blue color shader. And at this point, we should actually be able to look at this shader, and we should be able to tell exactly what's happening. So looking through it in Subshader, we're in the transparent queue. We're using standard alpha blending. We have Z-Write off, and there's not much happening in the vertex or the fragment program. So all we're doing here is returning a color, which is going to be blue with a 0.3 transparency. So the blue shader is on this blue plane right here. So as it is right now, the blue plane is behind the yellow one, and nothing's writing to the Z buffer here, so everything's functioning as you'd expect it to. So if we go over here, and I'm going to move the blue plane in front, you can see that in this part where they overlap, we're actually getting the order in which the colors are being blended together is what you'd expect. The blue plane is in front of the yellow, so we're actually going to be blending from the blue in the front, and the frame buffer will have that yellow color. So if we put it behind, you can see we get the yellow in the front. Now, if we just drop this guy into the queue, just one step before the other ones, what's happening now is the blue plane is being rendered before the yellow plane. So let's see what happens when we move it in front. So you can see that our blending isn't working the way we expect. The blue, even though it's in front, it's not actually being rendered first. So we're always blending kind of the yellow plane first and then the blue plane. So it's really important the order in which you're actually rendering transparent objects. If you don't render them in the correct order, you end up with oddities like that. So now that we're all in the transparent queue, we can see that based on the depth that we are, it's actually going to render that the way we would expect. Okay, so that's about it for this one. So now we have a firm understanding, hopefully, of blending equations, blend operations, and just we're kind of starting to see how this rendering pipeline's coming is put together. We're seeing the rendering order, how our tags and our cues up here affect the rendering order, and we should have enough of a background to start diving into textures in the next tutorial, and we'll start really getting into some stuff here that's more useful and a lot more fun now that we have enough background information. Thanks for watching.